Welcome to my house. Welcome to the Structure Talk podcast, a production of Structure Tech Home Inspections. My name is Ruben Saltzman. I'm your host, alongside building science geek Tessa Murray. We help home inspectors up their game through education, and we help homeowners to be better stewards of their houses. We've been keeping it real on this podcast since 2019, and we are also the #1 home inspection podcast in the world, according to my mom. Welcome back to Structure Talk. Tessa, wonderful to see you on the... And you know what? That's a terrible intro. We're going to start over.
That's the beauty. That's the beauty of recording.
That's the beauty of this. All right, let's do it again. I had Zoom on the tip of my tongue.
I knew you were going to say Zoom. Yeah.
Yeah. All right, let's do it again.
That's right.
All right. Welcome back to the show. Tessa, as always, so great to see you. What's new in your world, Tess?
Hey, Ruben. It's good to see you too. What's new? Well, things have been pretty busy with the, Your House Coach, the launch of my new biz, and also working on some other things too that are unrelated to House Coach with my other business, human design stuff. So that's been keeping me super busy. And I know you'll appreciate this. Just yesterday, I was over at my sister's house doing some mouse proofing based off of some of the recommendations from BOGO Pest Control, who we had on our podcast the other week. And I used up 2 bags of steel wool and a whole can of spray foam on her house.
Oh, good for you. Nice work, Tess. I'm sure it's going to be mouse free. Good job.
Yeah, I don't think so. There's actually like 2 porches and some areas that I could not get to at all, but I tried. So anyways, what's new with you?
Not a whole lot. Just I'm going to tease this one. There was it feels like it just happened, but I guess it was a couple of years ago, looking at my history, where I talked about this big water leak I had from this point of use water heater under my kitchen sink. And
yes.
I had put another one in, and this time you know what? I'm going to tease it. We'll tell the story later, but okay. I had another water heater leak. I had it leak a second time, and I'll leave it at that. I can't wait to share my story for our next podcast. Maybe next time we meet, we'll talk about it. Bruce, I'm going to leave you in suspense. We're not going to
tune in next week
over the show. You're going to have to tune in next week. You're going to have to listen to that podcast, but we need to bring you on, Bruce.
I was going to say, speaking of, let's introduce our guest.
Tessa, go for it. I want you do the intro today, Tess.
Well, so for everybody listening, we have on our pleasure to announce we have on Bruce Stahlberg with us this week. And Bruce, I would say you are you've been in the energy efficiency kind of consulting world for a long time, and actually I worked for you in college. You were one of the first people that taught me how to use a blower door and a manometer, and you taught me a lot about HVAC equipment. And so I am forever grateful to you and all of your knowledge, but you are still in that world and you're doing a lot of interesting things, and you know so much about HVAC, performance testing. You do trainings, and you even do your own consulting as well. So I want to hand this over to you, and I would love to hear you introduce yourself to anyone that doesn't know you and tell us a little bit about what you do, what your background is, and what you're working on these days.
Great. Well, and thanks. I always like to hear when I've trained someone in and they went on to use those skills. So that's a good thing. So I do like to share my knowledge. So it's a good place to be. So when I say that I've been in the business for a long time, it makes me feel kind of old, but I guess, if the shoe fits, right? So, so I started, I got a degree in energy management from Morehead State. It was a 4-year bachelor degree that was a little bit unusual back in the day. That catapulted me into some internships doing weatherization, got a job doing that. Then I went overseas and did some studying in Norway, sort of an energy planning, which was a great summer, I have to say. And I've just been kind of working definitely different parts of weatherization and energy efficiency. So I've done residential, multifamily, small business, commercial. I guess I get kind of bored, so I've been doing a lot of different stuff. I even snuck overseas for a few years and lived in South America and did like alternative energy type stuff. So, but recently I've been doing a lot more HVAC testing. So I'm an inspector for community action agencies. There's a lot of money right now, so they're installing a lot of systems, and we're doing a deep dive on the inspections on those. So I think it used to be we'd kind of just go out there and, do a little combustion analyzing and say, yeah, it looks pretty shiny and new, must be new. But we're doing a lot better job now of kind of holding contractors to some standards that make them perform a lot better.
Wow. Thanks, Bruce. Gosh, you have such an interesting history too. I forgot that you worked overseas and did all of those things as well. In addition to just working here and doing weatherization and consulting. But the first thing I want to dive into, I'm really curious about. So this podcast can get a little bit nerdy. So this is a warning for anybody that's listening. We are going to probably get a little technical today. I wanted to ask you what specific tests you use when you're out in the field checking these systems. And can you clarify what systems you're testing? Are we talking boilers? Are we talking furnaces?
Yeah, that's a great question. Most of what we're talking about is forced air. Okay. Although I just learned from another agency where, temperature rise can be tested on a boiler. You just have to have a little probe that would go on the supply and the return. Obviously, that would make sense because you want to dump the heat out in the building. So it'd be good to know what that is. So anytime we learn something new like that, we try to incorporate it into the auditors. I am teaching some HVAC classes for the state of Minnesota. So I'll be talking about that stuff as well whenever I learn something new, and we just incorporate that into the class. But on the forced air side, it's called static pressure. So you can focus, a lot of contractors focus on what's called temperature rise. You measure the difference between what kind of air temperature goes in, and then you heat it up and what's coming out. I find a lot of faults with that. First of all, thermometers sometimes aren't accurate. The location of doing the test can vary from person to person. So we can get, and the other thing about temporize is there's a 30-degree range that we're trying to hit. So it's not very hard to kind of get that range and still be, considered within spec. I prefer static pressure testing. So if you look on the nameplate, there is a total external static pressure rating for every forced air system. And we do 4 different test ports. Just a little tip for you guys. We don't drill holes in people's furnaces. We do test ports. Okay. It saved me a few times when people are seeing me drill into their brand new system. But it's what we're needed to do the testing. So if you get caught with that, you just say, well, I expected these test ports to be here already, so I could do my test. So should have been done before, but I'm going to do it now. So make it right. We do 1 before the filter, 1 after the filter, 1 before the A coil, and 1 after the A coil. Okay. And what that does is gives you pressure drops over the difference between the two. The filter gives you the pressure drop over the filter, and same with the A coil. And then the other 2 give you the total external static pressure, taking into account every elbow, every register, every air conditioning coil, etc. Those numbers are good to know, and they rarely meet spec. So just, the nerdy part of that is it's 0.5 inches of water column is a very common number. And we often see, 0.75, 1 inch of water column. So twice as much even sometimes. Now, a little tip for you, if you're talking to a homeowner, don't start talking about inches of water column. It's very, kind of weird numbers. So we usually use blood pressure and say, your doctor says you want 50, but your blood pressure is at 100 on your furnace. That's going to shorten the life of it. It's going to reduce the performance, make it louder, all kinds of things like that. So it's an easier way for them to understand.
I was just going to ask you, Bruce, so what does that mean when it's not falling in the manufacturer specs? So it can shorten the life of the furnace. Can it lead to comfort problems? And can you explain that a little bit more?
Yeah. And It's kind of like based on the sizing, which is also sort of the other side of the problem. When we put a furnace in, and the larger that it is, the more air you have to push through it to get rid of the heat. So if the ductwork stays the same, now you're trying to push more air through the same size ductwork. That makes the pressure go high. So I like the two-stage systems. In fact, I often will tweak them so they run on first stage only. Then I hold my breath, wait for a 20 below polar vortex, and call people up and see if I have to go replace their furnace or not. So far, it's been okay. So if it was a whole bunch of furnaces, I'd probably go back to South America on a one-way and just
take me back.
Take me back. But basically, I think we're oversizing furnaces, and then that in turn affects the static pressures. So if you can get people to kind of do a more accurate sizing, which is called manual J calculations, if we can get that more accurate, we can put in the right size furnaces, then our pressures come down and we do a better job of, and then airflow is the other side of that. So
how do you fix that problem, Bruce, if you don't have a multi-stage furnace?
A lot of the new furnaces come with like it's ECM motor, so it's a more efficient motor, and they have 4 different speeds, a lot of them, so you can change the wires around from like high speed, medium high, medium low, and low speed. It's a little technical. You have to get into the manual. Sometimes there's dip switches that we can move. Every furnace is a little bit different, so you kind of have to either get to know them or get into the manual or have a contractor that is willing to, take that deep dive. But you got to measure first, right? So
yeah. So usually it's an adjustment of the furnace and the blower and the motor. But do you ever have to like change the sizing of the ductwork, or is it sometimes a filter issue being really clogged and dirty, or an A coil being really dirty that can resolve those issues?
It certainly can. And even filters are, sometimes you see 1-inch filters that are highly pleated. They can contribute almost your entire budget just over that pressure drop. So yeah, go ahead, Ruben.
I got a question for you about that. I was attending an inspection with one of my inspectors a couple of weeks ago, and it was a flipped house. They had just replaced the furnace. The new furnace was like 2 months old, something like that. They had clearly been running the AC the whole time they're doing all the drywall sanding and all that. Yeah. The filter was just one of the dirtiest filters I've ever seen. And that says a lot because I've seen some nasty ones. And the furnace was just short cycling. So we pulled the filter out. There happened to be a new one in there. We put the new filter in, and it continued to short cycle even after we put in a new filter. And I thought the only thing that makes sense to me right now is that the A coil is so gunked up with drywall dust that's causing it to short cycle. There's no way we could get at the A coil. We could not create a test port, air quotes, large enough to see inside of it. And I'm just wondering, is it possible that A coil was so nastified with drywall dust that it would actually cause it to short cycle?
It's very possible, yeah, because we all know what sheetrock dust looks like, right?
Oh, yeah.
Super fine. So what I tell people, if you're going to be doing a remodeling project, you don't put your new furnace in, you put in an old one. Even if it has a cracked heat exchanger. I didn't say that publicly. No, but I mean,
we didn't hear you.
But you put in a furnace that you don't care about, because that sheetrock dust will get into the ductwork. And, the filter might do a good job, but sometimes there's leaks around the filter. So now it's getting on the blower motor, secondary heat exchanger, looks a lot like the A coil. Your A coil can get blocked up in a hurry. But I'll tell you how you can check it, Ruben.
Please.
So you can do a static pressure test on both sides of the coil.
Well, now you lost me.
Okay. All right. You've done a blower door test?
No.
No. Okay.
I have not.
So, do you have a manometer? Do you know what a manometer gauge is? A pressure gauge? So if you have a pressure gauge, you can put one test port right before the A coil and another one afterwards and measure that pressure, right, and then subtract the two of them.
Okay.
So that will tell you, okay, so imagine if the A coil was completely blocked, just like your filter was. Just imagine that drop is going to be very large, right? You're going to have a lot of pressure on one side and very little on the other side because nothing's getting through.
Yeah.
So that's one way to kind of see the A coil without actually seeing it. But then I also will take my snake camera and put a hole in there and see if I can't get it up in there to look at the A coil. Wow. So now I bought probably 5 different snake cameras in my life. Usually you go, I don't know what I'm looking at with this thing. So they're getting a little bit better with the light. And the one I have looked really good. It looks good when you're not inside a plenum, but sometimes you can't really see what you're looking at.
Sure.
But and I have taken, sometimes I'll even drill a 2-inch, take my 2-inch bit and drill a hole into the plenum. So I don't recommend that, but I really wanted to take a look at it. So.
But now I got to ask you, if you're drilling that hole, you're going to want to put that on the underside of the A coil.
Yes,
so you wouldn't be going in the plenum. You'd be going right in the cabinet for the A coil to see it, right?
In most situations, but when we install new furnaces, they're shorter. So in a new one, if the A coil stayed in the same spot, there's about a 6-inch gap between those. It gives you a chance to take a look at stuff.
Okay.
So
gotcha.
but not all of them are like that. And so it's a good point that you said. Sometimes it's a paired system, so it sits right on top. And then, yes, you wouldn't want to drill any 2-inch test ports.
Okay. Yeah. Okay.
You know what? So it's really interesting. You said, Bruce, let me just back up a second. You were mentioning one test method for furnaces was the temperature rise, and how you don't really prefer that method. You prefer the static pressure testing because you find it's more accurate or better at finding problems. Yeah. But what's, in the home inspection industry, it varies widely what home inspectors actually test on mechanical systems, depending on if there's state licensing requirements or just personal preference, the inspector's background. And there are inspectors out there that, might just open up the cabinet, do a visual inspection, look at the filter and call it good. Right. And then, structure tech, all those inspectors do a little bit more in-depth testing with checking temperature rise and doing a few other things, combustion analysis of the flue gases and stuff like that. But what I hear you saying is that's maybe not the best testing that we should be doing. Or what would you say is probably the most helpful testing that you can do to diagnose if the furnace has a problem and it needs some sort of, adjustments or tweaking?
Yeah, it's a great question. It sounds like you're on the right track. Combustion testing is good because you want to know if there's carbon monoxide. So that's very, very good. A lot of the new furnaces, there's not much they can do to tweak the efficiency. They set the gas valve and then you kind of get what you get. There's a little bit of variation. Most of the tweaking is done on the control board, which is down in the blower cabinet area. That's what I find. So this isn't like back in the day when you had an old furnace, with test ports and you tweak the amount of oxygen and watch your combustion. Those days are gone because those furnaces, don't exist. They're not being manufactured, and we usually are pulling them out anyway. So that's kind of where that is. Now, getting back to that A coil that we imagined was filled with sheetrock dust, if I did a temp rise on that, I would probably notice a problem. Right? Because I'm not getting rid of it. You might find a furnace that would short cycle because it's not getting rid of the heat. So those would be other indicators that there's a problem. So those, sometimes the test is okay, but I find that when I do a static pressure test, it's a very solid number. It doesn't jump around very much. If I'm on one side of the filter and someone else does it in a different area on the same area of the filter, same side, we get really pretty similar numbers. So I kind of like it as that. Now, there's one other main reason to do this. Doing static pressures takes me about 5 minutes. It's a test that is pretty accurate. I'd say really accurate and pretty easy to do. Not always. People do freak out because we might drill through an A coil and there goes, $5,000. You got to buy a new air conditioner. So we use a step bit. A step bit only goes in 1/8 of an inch at a time. Yeah. And I've never, well, knock on wood, I've never hit a coil yet. So,
okay.
So that's that part of it. But the other side is now using a Bluetooth software on your phone and a tool from the Energy Conservatory. You can measure the flow rate in about another 5 minutes. So in about 10 to 15 minutes, you can get a test that nobody has ever measured on that system, most likely. Because even when I'm talking to contractors, and you said that inspectors are going to get a wide range of services, right? We find that with HVAC contractors all the time. We spec out what we want. And I started asking him, I said, well, how do you measure the airflow? Tell me how you're doing it, right? Crickets, crickets, crickets. I've asked again, and they're just not doing it. And it's not, I'm not saying, I'm not blaming them or anything. It's just how the industry is. But now we have this new tool. It's called a digital flow plate. And it is really an amazing tool for really diagnosing. So here's an example. If you put in a new air conditioner, we'd like to have about 350 to 400 CFM per ton. That's a really good flow rate for Minnesota. And now we can measure it. But if I spend a lot of money on an air conditioner, really high SEER rating or whatever it might be, if it's not set up right, I'm not getting that efficiency.
Sure.
Huh.
Okay.
Yeah. So
flow rate is one of the, there's two things that are very important. There's actually, I'm sorry to interrupt there, but the Air Conditioners Contractors Association says there's 5 different things, but the main 2 are refrigeration and airflow. I can't check refrigeration. I don't have the tools for it. But this airflow test is very easy to do.
So this is a new tool that you're using in training some of these new HVAC contractors to use, but it's not widely used yet out in the field. Is that what you're saying?
Yeah, and I'm teaching. Well, I show it to the contractors, but they don't always run out and buy it right away. Mm-hmm. And just
change is hard.
Yes, change is hard. Yes, it is. And in some industries, it's very hard, right? Yeah. I did have one contractor. I was talking to him about oversizing, and he's like, "It's a hard habit to break." I was like, "Oh my God!" That was like what a response. But so, anyways, this tool has been around a long time, but it was a little more complicated before because you had to, there's filter sizes, can be 14 by 20, 14 by 25, and now they've really simplified it, and you can run it on your phone with a Bluetooth app. So it's much simpler. It kind of steps you right through it, tells you if you're doing it wrong. If it's giving you a bad reading, it'll tell you on that. You can take that report. It'll tell you what some of the solutions might be. You can email that report to a contractor, to a homeowner. So it's very, very useful information.
What are the data inputs for that?
So those 4 test ports.
Okay, for pressure.
That we mentioned before, those 4 things. And I'll just step you through it. It talks you through it. So you run one right before the filter. And this could be any filter. Could be really dirty, could be clean. Okay, put one before the filter. Your Bluetooth thing says taking test. Move it, take the next one. Steps you right through that. You pull the filter out and you drop in the right grid that has little airflow ports in it, and then run the test again, and it gives you the airflow.
Oh, okay.
And that's pretty much it. So I have it on my phone, but I don't think I can really step it through here. So if you go to the energyconservatory.com, you can find this tool. Okay. I do not make any money if they sell them. I should, as much as I promote them for them.
Too bad. Maybe after this. So this is Energy Conservatory is the same company that produces and manufactures blower door equipment and manometers and all these other tools that you're using to do this HVAC testing, correct?
That's true. And you do have to have a digital gauge that connects with the Bluetooth. So if you're buying this and you don't have any of that equipment, it's probably maybe around $2,000, but that covers all the different filter sizes. But a big chunk of that is the gauge. So, but now in the weatherization world, they already have the gauges because they're doing blower door tests already.
Sure.
Okay.
So they don't have to buy those gauges.
So can I ask you a question? What percentage of the HVAC contractors that are taking classes with you are doing this, static pressure testing and airflow testing?
Yeah.
I'm holding
Ruben
up a
just
zero
held
to
up.
the camera.
Yeah, held up a number 0.
Not many. And I'm not teaching them as often as I would like to. One reason that I do get their ear is we send them checks for the work they do. And so, we do have some control over them. And I'm rewriting some of the specs to kind of say, you have to set the airflow at this. And so we do have, but it's even at the cap agency world, we're slowly moving towards that. I sat next to a guy at a conference from Wisconsin, and he said they've been doing this for 15 years.
Oh,
Like they do it on the pre-inspection, the post-inspection. I was like, wow, that's impressive. So,
and that would be like that specific company, that's their standard, but is it a state requirement too sometimes, depending on your location?
Sometimes it can be a state, but this was through the weatherization.
Okay.
So statewide weatherization is federal DOE money, goes to the state, and then usually run by community action agencies.
So I gotta just for the listeners and for any home inspectors thinking about this stuff, I gotta say right now I'm just trying to think about action items, what to do with this information. It's great that you do this. We do some very basic stuff like checking temperature rise, and we'll be in a new construction house where the furnace manufacturer calls for a max temp rise of 60 degrees. We'll find 80 degrees and we'll say, hey, you got a problem here.
Yeah.
I think 9 times out of 10, the contractors come back out and they go, yep, it's all fine. No problem. I installed the right furnace. The city signed off on it. We're good. And then they go back to the seller and they say, yeah, your home inspector doesn't know what they're talking about. It's fine. And then we're just the lowly home inspector. We're not the HVAC contractor. They're the ones who know what they're doing. And then nothing ever happens and we get blasted. We look stupid. I can only imagine how much worse it would be if I was using an airflow
tool app and manometer.
Yeah. And so I got to say, I don't plan on us ever implementing some test that HVAC contractors don't understand and can't duplicate themselves. But if I was doing some type of troubleshooting inspection, comfort issue, or doing something more like what Tessa's doing now for her business, where she's doing a lot more diagnostic testing, it might be a cool tool for Tessa, or a good recommendation to refer out when we see a bunch of problems. And if we were going to do that, what type of professional would we call on? Because it clearly is not going to be your standard HVAC contractor. Who would we recommend if we're wanting to have this type of testing done? Right.
No, that's a good point. And I ran into that same problem when I was out doing small businesses. We were working in rural Minnesota, and you looked at this system and it's like 5-ton unit. Are you kidding me? Like for this small building, right? Well, who put it in? Well, the guy down the street, right? And who am I going to give this report? There's just not a lot of capacity. There's a lot of knowledge, capacity, and even desire to change, I guess. Mm-hmm. I would say this, though. When you measure, right? If we don't measure, we don't know. So when you measure with this report, it can be emailed to the homeowner, who I think, the homeowner is a good client for you guys, right? That's who's hiring you typically. So you could say the contractor could also come back with their measurement, and then they would say, well, we didn't do that, right? You can't control everything in this life, Ruben, in this world, right? So you do your work and you give them the report, and maybe they come out and they badmouth you, and you might never even know about it, right? But this document and showing homeowners what you're doing and why is usually pretty helpful. I talk a lot to homeowners, and the other thing is what I found is sometimes people say it's really loud. I've got recordings. I present at the Duluth Energy Conference. I've done the last 3 years, and every year is just a continuation of more HVAC stories. And what I'm finding is we can get by with much smaller systems, but we put in furnaces, and the woman said it wakes me up at night. And I'm like, oh my God, I don't know about you, but I love sleep, right? Quality sleep is an important thing in this world. So anyways, we tweaked that furnace to do a smaller amount of work, and it runs longer. And sort of rambling now, I guess, all about all that. But my point is that just trying to install systems that are going to last longer, be quieter, be more comfortable, and get more performance and energy efficiency out of them. It's kind of what we're trying to do, right? And
so these contractors that you're training, like what Ruben was saying, who do we recommend when we want that testing done? You do it, so people could reach out to you, Bruce, right, at your company, Affordable Energy Solutions. But are there other contractors out there that you've trained that can answer these questions and do these tests?
To my knowledge, as of yet, because like I said, we're within the agency I'm working. We're all going to buy them, so that for every auditor that goes out, they're going to have this tool. All the inspectors will have it. That's not the case right now. Like tomorrow, I'm doing one of the inspections because no one else has the tool. But as we start to push our contractors, then they can do that. What they're doing on the private side, I can't say, right? I don't write that check. I encourage people all the time, but it's, as a homeowner, you don't know, right? What's static pressure? What is flow rates? What's the, contractor does their work and away you go. But it's when it's really far off, that's when there's a problem. Otherwise, it does deliver temperatures that feel comfortable. So what's the problem? That's the hard part, right?
People get by with a furnace that's probably not working optimally or how it was designed to operate within manufacturer's limits, but it's still doing a good enough job that they don't know that there's a problem.
That's right. It's still heating. Now, the big thing, though, is for like air conditioning. What we want with air conditioning is long run times. So the coil then gets wet, gravity takes over, and it drips out, and it dehumidifies your home. So that's important. If we're running at, say, 600 CFM per ton, we can cool the house down. We just don't dehumidify. So it's not quite as comfortable. Yeah. So like this coming weekend, I'm glad I'm not running the marathon this weekend, by the way. But it's going to be a huge dew point, right? And so air conditioners that run very long, they do a good job of pulling moisture out of the air. And you can keep your home at 75, 78 degrees even. It feels comfortable. But when it's not doing that, you keep setting the temperature lower, trying to, get that comfort feeling going. So
can I just close the loop on this conversation? What I'm hearing you say, Bruce, is that like this type of advanced testing on HVAC equipment with flow rates and static temperature or static pressure is something that is happening now, this training for contractors that are involved in like weatherization projects.
That's correct.
But on the private side, there's really no push to kind of adopt these tests as long as there's no, demand for them. And so to find someone who can do them, it sounds like is just not even a realistic goal these days.
Pretty hard. And we didn't talk about sizing very much, but I was talking to a contractor about sizing. They're always concerned about leaving somebody short, right? It's going to be 20 below out, and they tell me all the time, that happens all the time. And I was like, I haven't seen it. I haven't seen that, but they tell me, I got calls all the time. And I'm like, you don't want to get, and I'm like, okay, but everybody that I call, and thankfully we had 15 below right before the conference. So I was like, this is perfect. I needed a polar vortex, for my presentation. People's like, I call them up and they're like, what are you talking about? And I'm like, perfect. That's exactly the answer I wanted, right? But the contractors have this fear. And so they oversize, manual J has a little fudging in it. So everybody's fudging. So we end up getting too large. Well, then they tell me, oh, if you want to go lower, we're going to have to rip out all the ductwork, for $3,000. And I'm like, I'm not talking about that. Okay. So it's a long process. When I present in Duluth, there's hardly ever HVAC contractors. They're not required to get CEUs, stuff like that.
Huh. Okay. Well, let's hope that, I wish, as home inspector, if you're a home inspector listening to this, or even just a homeowner, I guess my takeaway is that there's a lot of equipment that's installed by people who can put it in, but don't necessarily know all of these additional tests that you can do to verify and make sure it's working optimally. Right. And that's just the world that we live in. But there's things that can be done to make it better. And it sounds like you're one of the people, Bruce, that's slowly, hopefully, changing this industry and moving it towards, more efficiency and more durability and more comfort.
I hope I'm not the only one, because I'm like pushing Jello up a hill or something. But
yeah.
Kevin Brower is another consultant like myself. He bought one of these and is doing the testing. But I think more so than that is over time, when we educate people about what they're doing, that's going to be better. Now, one of our contractors, we went and met with them. Owners were there. I brought the tool in. I showed it to them. They are hiring a QC person to go back on all their furnaces, not the ones they've installed, but in the future, someone will install it. This person will go set it up, right? So that would be a good opportunity for them to have at least one tool where this person does that and measures things. And then you would think, if I was an HVAC contractor, I would promote that I'm doing that on all my private jobs and educate people, have all my salespeople talk about it. But, it's a tough competition. It's a tight market out there. People, they're throwing in a lot of furnaces. And so, but the big issue coming up right now is heat pumps, right? So we're all pushing to get in heat pumps. If we don't get that flow right, again, we're not going to be getting that performance. So
heat pumps is a whole other discussion, I feel like, for another day, but they're coming. Yeah. And especially with some of these federal tax credits and things and grants that are going to be available, heat pumps are going to be more and more common, I think. So,
yeah. So Bruce, if somebody did want to get a hold of you, how could they reach out?
So they can call. My number is 612-558-5959. My email address is just my name. So Bruce Stahlberg is STAHLBERG@gmail.com.
Okay. Got it.
Not very professional, but
it works. Yeah. Thank you so much, Bruce. It was a pleasure having you on. And I can't say that I feel warm and fuzzy after this conversation, but at least I feel like I know more information and hopefully can at least be more aware of what's going on in the HVAC world. And I hope that we continue to improve in this industry as we are in, all these other industries related to comfort and energy efficiency and performance. So thanks for coming on and sharing your wisdom with us. Yeah,
I'll just close. If you are an inspector out there, I started by doing static pressure testing. I didn't have to buy any special equipment. A pressure gauge and a pressure probe and then a step bit. So pretty easy to do. That can start to give you a lot of information. Makes you more comfortable with doing it.
Sure.
So that's a great place to kind of start. And then the airflow sort of naturally came to me. As soon as I saw the tool, I'm like, wow, this is really easy to do. So next week, of course, when water's leaking all over Ruben's floor, it's going to be a much more exciting podcast.
It's probably a little less technical, but
Stay tuned. Stay tuned.
Thanks, Bruce.
All right. Yeah. Thank you so much for coming on the show. We really appreciate it. Good to see you again, Bruce.
Sounds good.
Yeah.
All right. Take care. All right, Bruce Bruce, if you would, just stay on a second.
Okay.